Welcome to lecture 11 of Python module, and in this video we will talk about 4 pillars of OOP. Before talking about them, let's first understand what is a constructor in Python. So this is the terminology which you will encounter when you will deal more with OOPs. So constructor is nothing but the init method we discussed in our previous video. And what is this method? So this is used for instantiating an object, and this is called automatically when an object is created. Now we have two types of constructor. One is default and one is parameterized. As the name suggests, default has only one argument, which is self. And self is actually a reference to the object or instance that has been constructed. But in the parameterized constructor, we have more than one argument. The first argument is self, and rest of the arguments are provided by the programmer when that programmer is instantiating an object. Now let's understand the difference between two using an example. So here overall what we are doing, we are creating a class person, and inside that we have two methods, init to actually initialize the attribute and display detail, which is a method which will display the detail of each object. Then finally we are creating an object person of person class, and then using this object we will be calling a method display detail. Now you can see the difference between the init method. In the first screenshot, init method has only one parameter, which is also default. So here self is actually indicating to an object person, and this person object is calling a method display detail. But when you see screenshot second, you can see that inside init method, we have more than one parameter. Now the first parameter is self and it indicates to an object, but the last two parameters are the name and age. So basically when you will create an object, it's important to actually mention the name and age as well, which will be mapped to self.name is equals to name. So what we are doing, we are actually mapping the name attribute or name parameter to the object attribute name. So as you can see that when I'm creating an object person in this case, inside person class, I'm also mentioning its name and age. So this is the difference between default and parameterized constructor. Now let's talk about the first pillar of OOP, which is inheritance. So inheritance is a capability of one class to derive or inherit the property from another class. The class that derives the property is called a derived class or a child class, and the class from which the properties are being derived is called the base class or a parent class. Now because of this inheritance, the real world scenario, for example, you inherit properties from your parents' mother and father. Similarly, the child class can inherit all the attributes and methods from its parent class. So this real life scenario can be copied using OOP's inheritance. So that is why this is one of the pillar of OOP. Now let's see what are the benefits of inheritance. So the first advantage is that it represents real world relationship. Second, that it provides the reusability of a code. So now you don't have to rewrite the same attributes and method for the child class. All you need to do is inherit your parent class. It is also transitive in nature. So for example, class C inherits class B and class B inherits class A. So at the end I can say that class C is also inheriting class A. Now inheritance offers a simple, understandable model structure, and less development and maintenance expenses result from the inheritance. So now let's understand the different type of inheritance available to us in Python. So there are total 4 types: single, multi-level, hierarchical, and multiple inheritance. So let's see each one of them. So single inheritance involves a derived class inheriting from a single base class. It represents and is a relationship where the derived class is a specialized version of a base class. So as single inheritance term signify, you only have one parent or one base class from which you will be inheriting all its property and method. For example, here we have a parent class vehicle, and now we have a child class car. which is inheriting vehicle. Now, how I know that class car is inheriting class vehicle? For that, there's a simple syntax that when you are declaring a class car, which you want as a child class, so inside parentheses, all you need to write the name of a parent class. So this particular line indicate that car class is inheriting vehicle class. Therefore, car is a child and vehicle is a parent. Now you have to create an object of a car to access all its method, and now you can actually access both the method which is declared inside vehicle and the method which is declared inside the car. So now let's see what is a multi-level inheritance. So this involves a derived class inheriting from a base class which itself inherit from another base class. So basically it is representing a hierarchical relationship where classes are organized in a layered manner. And from this you can actually see that inheritance is transitive in nature. So for example, we have a class animal which is getting inherited by mammal. And similarly, this mammal class is getting inherited by dog. So now dog can actually access all the methods inside all of these classes. Why? Because dog is a child of mammal and animal both. So breathe, feed milk and bark, you can access all these methods while creating an object of a dog class. Now let's see what is a hierarchical inheritance. So hierarchical inheritance involves multiple derived classes inheriting from a single base class. It represents a specialization of a base class into multiple subclasses. So basically here you have more than one child class. For example, here we have a class animal which is getting inherited by two classes, cat and lion. So basically when I will create an object of cat and lion, both these objects can access method breathe. Why? Because these are the child of class animal. So as you can see that when we are creating an object of cat and lion, you can access the breathe in both the cases and their individual methods as well. Now the last inheritance type is a multiple inheritance, and here you need to understand what's the difference between multi-level and multiple. In multiple inheritance, it involves a derived class inheriting from a multiple base classes. It allows a child to inherit attribute and method from a multiple sources. For example, here we have a class swimmer and we have defined a method swim in it. Now we have a class walker where we have defined walk method. Now I have a class amphibian. Now amphibian is actually inheriting features of two classes which I am mentioning using this syntax. Inside parentheses I have passed the name of both the classes. And it has its individual method croc. So when I'm creating an object of amphibian, it can actually access method of walker and swimmer because it's a child of both the parents, right? So actually multiple inheritance is just a reverse of a hierarchical inheritance. Hierarchical inheritance has multiple child and multiple inheritance has multiple parent. So that's the difference. Now we have completed one pillar of OOPS. Now let's understand what is encapsulation in Python. So this is also a very important concept in object-oriented programming that combine data and method within a single unit called a class. So basically using a class is actually you are using encapsulation technique. So it helps in hiding the internal detail of an object and providing a controlled interface for interacting with the object. Now let's see how to achieve encapsulation. So it is achieved through the use of access modifier. So what are they? Access modifier control the accessibility of a class members. And when I'm saying class members, we have two things in class, attribute and method. So both of them together are known as members of class. So basically access modifier control the accessibility of class member from outside the class. And we have two main type of access modifier. One is protected and one is private. So let's see what are they and how we actually define them. So protected members are denoted by a single underscore at the beginning of their name. So for example, you are declaring any attribute or any method in a protected way. So all you need to do is use underscore at the beginning of it one time. So what will this protected member do? It allow you to access from within the class itself and also from any subclass that inherit from a class. And what is a private member? As the name suggests, it brings more privacy. So to declare it, we will be using double underscore at the beginning of their name, and they can only be accessed from within the class itself and cannot be accessed from outside the class or any other subclasses. Now let's move towards the third pillar of OOPS, which is polymorphism. So poly means many and morphism means form. So in programming, polymorphism refers to a function which has same name but has been used in different ways and in different scenarios. This makes programming easier and more intuitive. For example, we have a class shape which has a method draw. But when I am creating the same method inside different classes like circle, rectangle and square, the same method draw will result different output. So that is the different form of the same function. Let's see more about it through an example. So here you can see that we have two lines in which we are printing the sum of two numbers, and in second we are doing the concatenation. So operator overloading is a concept of using an operator beyond its predefined purpose. In this example, the plus operator is performing addition, and in the second line it's performing the string concatenation. So this is basically the operator overloading, therefore one operator but different work of it. So that is actually an example of a polymorphism in Python. Now let's see the function of polymorphism in Python. So here you can see that we have a function length, which is actually calculating the length of a string, list and dictionary. So this is the best example of an inbuilt function that shows polymorphism. So basically it has different parameters and different type of data inside its parameter, but still it is working. So we have one function but different forms of accepting its parameter. Now let's see an example of a class polymorphism. So we will be explaining it using an example. So here you can see that we have two classes, cat and cow. Each of these has three methods, what is an init, then info and then make sound. But here you can see that init method is same in both the cases, where it is actually taking the attributes name and age of an object. While the info and make sound method is specific to the class, both of them actually print different statements. Now we have two classes and they have the same methods. So when I'm creating object of each class, cat and cow, you can see that I am calling the same method on both the objects, which is makes out and info, but in the output we are getting different result. Why? We are getting it using the polymorphism nature in Python. I have the same name of method, but since I'm using it inside different classes and then calling individual objects, they will be resulting different output. Now let's talk about method overriding and overloading. These are the two things which are very important whenever we talk about polymorphism. Method overriding is a concept where a subclass provides its own implementation of a method that is already defined in its superclass. We already know that a subclass inherits all the methods and attributes of the superclass. So a method which is already defined in a superclass will be accessible to a subclass, but then the subclass also has the same name method and its own implementation. So how to deal with it? Let's see an example. So here you can see that we have a class animal, and this class has been inherited by a class dog. Both of these class has the same method make sound. But when I'm creating an object of animal class and then I'm calling a method make class, I'm getting an output of the class animal, that is the animal makes a sound. But when I'm creating an object of dog class and then calling that same method make sound, I'm getting a different output, and this time I'm getting the dog barks. So basically, method overriding allows subclasses to provide their own specific behavior from inherited method, allowing for more specialized and customized functionality. Now let's see what is method overloading. So allow a class to have multiple methods with the same name but different parameter. The appropriate method to be executed is determined based on the number of arguments, type of arguments, or both. So basically you are overloading a same method, and how? But different parameters. So how to actually determine which method to implement? So it can be done with the number of arguments or type of arguments. Let's see an example. So here you can see that we have a class calculator and it has a method add. And this add method has two parameters, num1 and num2, and self is a default parameter which is indicating the object of a class calculator. Now I'm also creating another same method add, but this time we have three parameters, num1, num2 and num3, which returns the sum of all these three numbers. So when I'm creating an object of calculator class, and for the first time, I'm actually calling the add method, but passing only two arguments. It is giving me an output 5. And at the second time, I'm calling the same method add and passing the three parameters. And again, I'm getting the correct output. I'm getting no error. Why? Because I have declared the same method add with different parameters. So Python automatically maps to what method we are calling. So method overloading allows us to have multiple methods with the same name but different parameter, providing flexibility and convenience when working with different variations of the same operator. Note that the method overloading is not directly supported in Python. This is just an example of what method overloading is. Now we have completed the third pillar of OOPS. Now it's the time of fourth and the last pillar, which is data abstraction. The process by which data and functions are defined in such a way that only essential details can be seen and unnecessary implementations are hidden is called the data abstraction. So the main focus of data abstraction is to separate the interface and the implementation of a program. This can be achieved through creating abstract classes and then inheriting them later. So how to create abstract class? What are the different type of methods we have in data abstraction? Let's see them. So abstract classes, these are the classes which cannot be instantiated. Therefore, we cannot create objects of the abstract class, and these are only meant to be inherited. So the only way of using the attributes and methods of abstract class is to inherit it. You cannot instantiate an abstract class. Then an object of a derived class is used to access the features of a base class. An abstract class is also termed as an interface because its primary work is to separate the implementation and interface. In Python, we use the not implemented error to restrict the instantiation of a class. Any class having this error inside method definitions cannot be instantiated. Now let's see an example of the abstract class. So in this example, we have created an abstract class fruit. We derived two classes, mango and orange, from the fruit class that implement the methods defined in the class. Here, the fruit class is the parent abstract class, and the classes mango and apple becomes the subclasses or the child classes. We won't be able to access the method of a fruit class by simply creating an object. We will have to create the objects of a derived class, which is in this case is a mango and apple. So here you can notice that these methods are unimplemented in the parent class. So they are only defined in the parent class or the abstract class, and its definition of work has been defined in the derived class. So that's the abstract class. Now how to create it? So Python does not support the abstract class itself. So one thing to note that method overloading and abstraction is not directly supported by Python. So to achieve that, we use the ABC module of Python, which provides the base and the necessary tool for defining abstract base classes. So to define an abstract class, you have to do two things. One is to import ABC. What you will be doing, you will be writing from ABC, import capital or uppercase ABC. And now when you will be declaring a class of abstract type, you have to write inside the parenthesis ABC, which you have imported from the module ABC. So I hope you get an idea of how to work with the abstract class. Now let's understand the methods in abstract base class. So ABC is defined in a way that the abstract method in the base class are created by decorating with the @abstract method keyword, and the concrete methods are registered as the implementations of a base class. So for example, here you can see that to implement abstraction, it's important to create an abstract class. So Python does not support it directly. We need to import ABC from the ABC module. This is what we have done in line number 1. And then we have created a class parent, which is abstract class. How we know this? Because of this parenthesis inside ABC. Inside this class, we have defined a method common function, which will be printing I am a common method of parent. Now I'm also defining an abstract method, and how to tell this to a computer? We will be using a decorator abstract method, which will be actually a pass. So we are only defining a method. Its implementation we will be writing in its subclasses or child classes. Now we have two classes, child1 and child2, which inherit parent class. And inside this, we have actually declared the implementation of the ABS function, which is an abstract method. Now, since you know what is an abstract method, it's important to know what is a concrete method. So this is the registered method, which are actually the implementations of a base class. An abstract class can have both an abstract method and a concrete method. So concrete methods are the one which you define, and this can be accessed using the object of an abstract class. But to actually use the abstract method of an abstract class, you cannot declare an object. Instead, you have to create an object of the subclasses. Okay, so to declare an abstract method, we will be using a decorator and we will be using a pass keyword. So we only declare method, we define its implementation in the subclass. That's all in the abstraction, and now we have also completed the fourth pillar of OOPS. Let's revise what all we learned in this video. First, we saw what are constructors. So these are the init method which are called automatically when the object is instantiated, and we have two type of constructor. One is a default one which has only self as its parameter, and one is the parameterized constructor which has more than one parameters, and while creating an object you need to write those parameters as well. We saw the first pillar of OOPS, which is inheritance, that allow class to inherit another class attributes and methods. We have four type of inheritance: single, which is a relationship; multi-level, that shows transitive nature of inheritance; hierarchical, where we have more than one child class; and multiple inheritance, where we have more than one parent class. Then we saw the second pillar, which is encapsulation, which means you are binding the related data together. Class is an example of encapsulation, and we have two type of access modifier. One is private and one is protected. To declare private, we use double underscore, and private modifiers, which is method and variable, can only be used inside a class. While in protected modifier, where we declare it using one underscore, we can use it inside the subclasses as well, where the class is getting inherited. Then we saw the third pillar, which is polymorphism, that shows many forms but one function. We saw its example in operator overloading, where we saw that the plus sign is actually doing addition and string concatenation. Similarly, in method overriding, The subclass and superclass has the same method name, but subclass has its own different implementation. So that is method overriding, which we saw in inheritance. Similarly, we saw what is method overloading, where inside a class I have a method. So that method is repeated twice and thrice, but the only difference is inside the parameter. So in that case, which we saw in the example, we have the add method. In the first case, we have 2 parameter, and in the second case, we have 3 parameter. Then finally, we saw the fourth pillar of OOPS, which is data abstraction. That is nothing but hiding or differentiating between the interface and implementation. In data abstraction, we saw that we need to create the abstract class, and for that we need to import a module ABC. And we have 2 type of methods in data abstraction class. One is abstract method, which is only declared inside the abstract class. It is only defined, but its implementation is written inside the subclasses. And abstract class cannot have object, or it cannot instantiate its object. Right. And then we saw the second method, which is a concrete method whose implementation is written inside the abstract class, and this method can be accessed using its object. So that's all in this video. Thank you.